This will be my next project. I've had this package for maybe 2 months. Oh, it was torn open. I bet they referred to the address in here. So this was shipped from QRP Labs. They're primarily concerned with amateur radio stuff. And in fact, it says ham radio kit components for experimental and educational purposes. Whole bunch of stuff here. So primarily, we have this VFO signal generator kit. In order to complete this kit, we need a SI 5351A, which is a programmable square wave generator. And then we need the program. So this will make a variable frequency square wave generator that operates somewhere between 4, maybe 3, to 150, maybe 200 megahertz. If we want to make the oscillator stable frequency-wise, we have a GPS receiver here. With some cable and an antenna and a receiver. So with this, we can make a frequency stabilized, that is GPS stabilized frequency generator. You can also make a clock, because you can derive time and date from GPS signals. I have one of them. And I have one of these oscillators completed, but I use it only as a 10 megahertz reference for the shop here. My intention is to make a sine wave oscillator, GPS stabilized, with a frequency range of 4 to 30, more or less, megahertz. To do that, we need a bunch of low-pass filters, harmonically related. Well, I told you that QRP Labs is mostly amateur radio related. So we have some filters here, and they're indicated by amateur radio bands in meters. So for example, here's a 60 meter, 40 meter, 20 meter, 30 meter, 15 meters, and 10 meters. These are low-pass filters, and they, up to the low-pass point, inputting a square wave will output a sine wave. Because they eliminate the harmonics. In order to switch between these 6 filters, we need a relay switching kit. The relay switching kit mounts the low-pass filters and control relays on a board. The program chip, depending on the frequency programmed into the chip, selects which filter is appropriate. I hope that made sense so far. QRP Labs sells all of these, I believe all of these, as individual kits. But since the goal here is to develop a signal generator, not an amateur radio frequency generator for any specific amateur band, they have what they call, I believe, we'll see what it is, a sine wave VFO signal generator set. That set consists of all of these things. Now the basic kit, less the GPS receiver, costs a little less than $40. The GPS receiver costs an additional $20. And I believe I ordered a knob. It's not here, but we'll get to that. So this is a kit, a set of kits that are all required to put together this. QRP Labs doesn't furnish paper copies of very much. Clicking on these links will yield instructions on building and operating the device you click on. The synthesizer, the 6 relay filter selector kit, the individual low-pass filters, and optionally I got the GPS receiver and a VFO kit. Assembled, the front of the kit will look like this, with the display here, the oscillator here, the frequency synthesizer here, the relay switching system here, and the low-pass filters here. There is a mini instruction manual for how this thing is assembled and how it works. A little bit more detail. But in order to assemble the entire kit, you want to download the individual instruction manuals that cover the individual bags. And you want to download the latest version, or the version that corresponds to your board and program. Because I've had this kit laying in the shipping container, I want to check the, for example, this is the programming version 1.04, before I download any specific stuff. When I ordered this stuff, I ordered from QRP Labs the VFO enclosure kit. It obviously is not here. It came in a separate package. This contains the kit and I think some parts. It was drop shipped from China. I didn't order it from China. QRP Labs ordered it. So QRP Labs must have an arrangement. Here's the front and rear panel already silk screen, drilled, whatever. Here's the enclosure and a bag of components. The switches, power jack, DIN connector that would be used to build the kit and enclose it. Now, I did check on the price of just this bare enclosure. It was actually more than the price of ordering it from QRP Labs. I don't seem to have the price for the enclosure kit. It was very, very economical. So I'm going to determine what version of everything I have and download the appropriate documentation. I've gone back to QRP Labs website and downloaded the instruction and construction manuals for the latest revision. Now, ironically, this board is marked revision 4, but the link on the website told me that this would cover revisions 1, 3, and 4. It just skips revision 2. This is the contents. We really have 2 packages. One was marked VSO signal generator. The other was unmarked. The unmarked bag had the rotary encoder with push button, little piece of wire, and the pre-programmed information. This front panel came with the enclosure and was not part of this kit. 1602 display, some headers, male and female, a socket for the chip, hardware, potentiometer, 2 potentiometers, I guess, and 2 push buttons. Not a lot of work here. So I'll just follow the instructions and we'll end up with hopefully a working oscillator mounted on this plate. Very early in the assembly, you're going to be asked to install these 2 sockets. They straddle the CPU. In order to hold these things in their position, I've taken the uninstalled male pins and used them as spacers. What that allows you to do is hold these things in position, perfectly parallel and vertical. So here's the VFO. Well, the VFO is done. I did mount these 2 headers, I believe. Well, they're plugs. I believe they're to be used with the relay board. And the next thing to do is to build the SI 5351, because this will not output a signal without that. I used some DuPont wire here. Did not use the wire that came with the kit. And here's the encoder. Now, the instructions for wiring the encoder are easy. I did put heat shrink on, not so much for insulation as to give this a little bit of rigidity. This is pretty thin wire. I mount it to the faceplate. So these short standoffs here came with the enclosure kit, as did the knob. See how much of it is unpopulated? So don't feel intimidated when you pull this board out and think, holy shit, there's a lot of work to do there. If you're just making a VFO signal generator, this is it, except for the oscillator board. This is the synthesizer board. It had this piece which I broke off. I believe there's more components here than there were on the oscillator board. They're all through hole, a couple of headers. I'll assemble this next. I finished this synthesizer board, plugged it into the main board, and what we have now should be a fairly good square wave generator, 3 volt peak to peak, from say 4 to 150 megahertz. Now to convert that square wave to a sine wave, I'm going to have a bunch of low pass filters attached to this. And those low pass filters will be selected by the frequency setting on the front panel, operating various relays on a relay board. In order to do that, after completing all of this, I need to insert these components. I've already inserted these 2 headers. A diode, a relay, a jumper, and a capacitor. I should be able to find them in the relay board kit, so I'll go look for that now. So here we have the ultimate relay switched LPF. Well, there isn't an LPF included in this. There, however, are included, I believe, the relays. I've got a board. Six little relays. Set of double parallel 2-row headers. And a diode. So the VFO board has been modified for use with this relay switching, I guess it goes that way, switching relay board. This diode was included with the board kit. This capacitor was one of 5 originally supplied with this kit, of which I only used 1, and then I used the second one when I moved to ready the board for this and the jumper. So now I'll proceed to build this board, this back in. I thought that before I put the relay board on here, I should set this potentiometer. And there we go. Now, I did not opt to install this optional resistor. I actually put a jumper in place of R4. But it suggests that if you want more sensitivity in this contrast adjustment pot, you should put a 220K resistor rather than jumper it out. I would strongly recommend that. I had to remove the jumper and install this resistor in order to be able to hit the sweet spot on this. I'm not sure what to do now. I just wanted to set the contrast. Well, the next thing to do is to wind the coils and build 6 low-pass filters. One filter will, 5 of them will fit across these relays. One fits down here across this relay. So this is the lowest, and let's see, then this is the highest, and the 4 others are increasing in frequency. I'm not sure if I mentioned or not when I did the additional work to make this board compatible with this. I installed this dual header, which was part of this board kit. This board just consists of 5 relays, 10 sockets, and 5 diodes. There's snubbing diodes for the relays, and this connector here. So there we go. And it should look just like this picture when the low-pass filters are installed. I guess it's this way in the photograph.